So for this example, we are exploring the graphical method of simultaneous equation. So out of the three methods of simultaneous equation, elimination, substitution, graphical method. Graphical method is the one that a lot of students might tend to forget or they find very difficult to relate. So the key idea is in this box. So when we say the solution to a pair of simultaneous, we are referring to the x and we are referring to the y. So in all your previous method, when you solve simultaneous, you always get the x or y. So in this case, when you draw the graph, it will come from the intersection. It will come from the coordinates of the intersection. So the coordinates will look like this. The intersection is like the meeting point. The meeting point of the two lines. Okay, so let me just show you the idea first. So like for example, in part A, you got equation 1 and equation 2. So if you want to, you can try part A using like elimination or substitution. So if you look at part A, right, I think it will be quite easy if you do it by the elimination. So we will be drawing two graphs. Okay, so for the first equation, okay, this will be the line. So how would you get the two graphs? So you got to perform your set one method. That means you got to come out with the table and draw the line. Okay, so later on, I will add on the table for you. So right now, you assume that you are able to draw it out first. Then the second line is here. You can try to color the line so that it's easier for you to see. So you realize that they actually label the equation. So for you, when you try to do it later, you need to label the equation. So where is the answer? The answer comes from the meeting point. So you need to dot that meeting point. So if you read the coordinate, it is 2, 1. So the solution will be x equal to 2, y equal to 1. So you can present it this way. So that can be the presentation. Okay, so let's look at example part B. Part B is the same thing. So you got two equations, which you can do by substitution or elimination. But in this case, we didn't. We choose to draw out the first equation. So when we draw out the first equation, you gotten the line. So when you draw out the second equation, that will be another line. So after you gotten the two lines, you go for the meeting point. Once you go for the meeting point, you look at the coordinates. So the coordinate is 3, 1. So x is equal to 3, y is equal to 1. If you go by the elimination method or substitution method, you will get the same answer. Okay, so the dotted line is a must. So you must show the dotted line. You got to tell people where you get the intersection point. So you got to do the dotted line. Okay, so let's try two more questions. Okay. So equation 1. Equation 2. So the first equation, we'll draw it out. Okay, later on, we'll talk about the actual drawing. So that will be my first equation. The second equation is actually a horizontal line. So y equal to a number is a horizontal line. So that is something that you learn in Sec 1. So some of you might forget. So y equal to a number is the horizontal line. So the horizontal line is here. Okay, so will they give you a vertical line? Yes. So you can have x equal to something that will be a vertical line. So if your teacher has recapped a bit of your set 1 work, your teacher should have recapped it. So where is the intersection? Okay, the intersection is here. Okay, the coordinate is 2.5, 1. So the solution will be x equal to 2.5, y equal to 1. So it's quite straightforward, unless you get yourself very, very confused. So equation 1, equation 2. Okay, so let's try to get the idea first. So the first equation is here. Okay, let me draw properly this part. So the first equation is here. Okay, I don't know. Okay, sorry, let me just draw it properly. And the second equation. So the drawing involve the drawing will involve having a table. So later on we'll look at having a table. So look for the meeting point. Okay. Do the dotted for the meeting point. So the coordinate is -2, -3. So -2, -3. So the x will be a -2, the y will be a -3. So that is the idea behind the graphical method for the simultaneous. You must know where to locate. So right now, if you have an idea of where to locate, we got to go to the actual drawing. So the actual drawing will involve 2 tables. So like equation 1 is 1 table. So this will be the table for equation 1. So you fill up the table according to the formula here. Then you go and plot. Okay, plot. Okay, when you plot, even though it's just a very short line, okay, use your ruler to extend it. Okay, and you remember to label the line. Okay, then for the other equation, okay, you get another table. So substitute inside, get the values, put in the x equal to 2. So this will be the formula. So put the x inside. Then, okay, don't forget, this is like a coordinate. So all these are a pair of coordinate. Okay, same like here. Just now I forgot to mention this. So this is 0, 0. This is 1, 1. This is 2, 2. So that's how I gotten the points. Okay, so now I'm going to do the second line. So you will get 1, 3. You will get 2, 2. You will get 3, 1. So it's quite a short line. So don't be stingy about it. Okay, extend the line. Extend the line, write the equation. Okay, look for the intersection point. Remember, you must show the dotted line. So the intersection point is 2, 2. So the intersection point is 2, 2. So the solution will be x equal to 2, y equal to 2. Okay, so that will be the method you will need to execute. So during exam, sometimes you will be provided with graph paper, or they will have a grid for you on the actual exam paper. Okay. However, there are two special cases. So there are two special cases which I'm going to show you here. So part C is a part C is a special case. Okay, so let's talk about the two equations first. So the first equation. So this is the first equation. So we make y the subject. We make y the subject. So that it's easier for us to fill up the table. So put in the numbers. So you will get the coordinates. So put in the numbers and you will get the coordinate. So then you start plotting. If your coordinate doesn't form a straight line, then you might have made a careless mistake somewhere. So that will be the first equation. Okay, let's go to the second equation. So this is the second equation. So I'm going to plot. Okay, I'm going to fill in the table with that. So after you fill in the table, you will get 0, 3. You will get 1, 1. You get 2 minus 1. So this is your second line. So why is this a special case? You realize that there are no meeting point. You realize that the two lines doesn't meet each other at all. So in this case, right, if you look from a graph, there are no intersection. So when there are no intersection, the simultaneous has no solution. So you cannot get any answers at all. Okay, so one of the reason is the two lines, you realize that they are moving in the same direction. So there's a special name for this situation. So these two lines are considered parallel line. So parallel line means they got same gradient. So currently we don't use so much of the term parallel line. So in the upper side, you will explore more of this idea. But if you look right, both are moving in the same direction. So like both are moving down. So in this case, they don't meet each other forever. So in this case, there is no solution. Okay, subsequently, there's also another special case. Okay, another special case will be on part E. So another special case will be on part E. Okay, you look at the first equation. Okay, I'm going to fill up the table for the first equation. So you will get 3 coordinates. So plot the coordinates. So extend your line. So this will be the equation minus x plus 3. Okay, then let's talk about the second line. So the second line will give you another table. So we actually manipulate the line. So I show the manipulation first. So we shift the 2x over. Then we can divide by 2. Okay. So you can actually do this. Okay, this is essentially the same. It's actually same as 6 over 2. So that's how we get the 3 minus x. So I'm trying to simplify until it's actually easy for us to calculate. So here I can put in my x. So I can put in the -1. So when I put in the -1, I got the 4. So when I put in a 0, I got a 3. When I put in a 1, I get a 2. Okay. So you still get the 3 coordinates. Okay, let's try plotting the 3 coordinates. So if you try plotting the 3 coordinates, you look at what happened. This is the second line. So do you realize the second line is like stacked on top of the blue line? So the two equations, the two lines are overlapping. So when the two lines are overlapping, there are many intersections. So there are many meeting points. There are many intersection coordinates. That means they can meet here, they can meet here, they can meet here, they can meet here. So they can meet at a lot of points. So essentially they meet at so many points. So the description here is right. This pair of simultaneous has infinitely many solutions. So when the two lines are the same, they will have many solutions. So there are too many for you to state any solution already. So you will just say that there are infinitely many solutions. So this will be one of the higher order questions that they will test you. So in what situation will you have infinitely many solutions? You will have many solutions when the two lines are overlapping. Or essentially the two lines are the same line. Okay, so it is also one of the extreme case. So in this case, we got too many solution already. So in the previous case, we got no solution at all because they just never meet. So other than that, these are the two extreme situations. Other than that, right, it will be more of you look for the intersection point. Okay, so you will need to try to complete set F. But you got to bear in mind the two extreme case.